Okay. Last year we had a bunch of things that kind of went dy dt equals y whatever y ky basically. Okay. That is really convenient. We have something growing like this.
You said the first one was
something like that. No? And so it models a lot of things that naturally occur. There is one additional piece they expect BC students to be able to do, and that is what's called logistical curve, which is one that starts off looking just like what we have there, but then it has to tail off. An example I give you is, you just have bacteria in a petri dish. It'll grow like crazy until it hits the walls. And when it hits the walls, all of a sudden it stops. It reaches a maximum. And so it steadily tails off on that maximum, okay? To make that work, the equation we use is dy dt is equal to ky, just like we did before. That gives the exponential growth. But then we modify it by multiplying by 1 minus y over L. What that does is when y gets close to L, what does this whole thing become? 0, which means that the slope goes to 0. Now initially it's blowing up. This is the exponential piece. And then, whoop, we're going to make it go to 0 now. Okay? All right. Now the problem with this is the calculus for this is nasty. Okay? Because what do you have to do in order to integrate this?
Good question.
Well, the instructions are on the next page. I'll walk you through it a little bit. Remember, we got to get all the y's over here and all the t's over there. Well, there's no t's, right?
Yeah.
So move all the y's over by just basically dividing by 1 over ky times 1 minus k over L equals, let's go ahead and put the dy over here. dy equals dt. I'll put a 1 over here just for placeholding purposes, right? Then the next step as you follow along is they go, well, we can't. Try integrating that sometime. That's not going to work real well. Okay, so to integrate it, what they did is
they have the k on the left side, or is it still on the right side?
Did they left k? They left k over there. You're right.
Yeah.
Let's put the k over there. All right. Saves me having to put it back anyways. This should be k over. This should be y. What did I do? This should be y over L.
What?
Losing my mind. Okay, so far so good.
Yeah.
Now to make this thing work, we're going to have to figure out a way to separate the variables. I got something multiplied by something. So what they did, which is really creative, is they extracted a y from this. Factor out a y from this, so I'd have 2 different factors.
Oh.
Okay? And so how do you do that? Well, you cry a lot, and then you try to figure this out. Actually, what they do, they multiplied. I lied, they didn't do that. What they do? Hold on. Oh, yeah, they did. Okay, here's what they did. They said, all right, simplify this side over here.
Yeah,
Simplify this piece right here. They said y, we need a common denominator. So we're going to write this as L minus y over, that would be over L. Now, I thought I had it for a second.
Not that it was y over y minus y over L.
Is this an L?
Yeah.
Right, do a common denominator.
Yeah. What?
We would do L minus y over L. Yeah, am I wrong?
Are you getting the right answer?
Well, I'm not getting the right answer, but
So
that's
you're
not
wrong.
important. We have to figure out how to make this work. Oh, okay. So then I can flip this up, right? Because it's just an L on the bottom. Does that make sense? So I can flip this up, and I go L over here, and I got y times L minus y. What the heck?
Is that what they did? I don't think that's what they did.
Yeah, they're not going that way. Anyway, the math is there. What the heck?
What?
Should be able to do this. I looked at it this morning and said, oh, I can do that. Where did the L go? They did L minus y. That works. There should be an L that flipped up on top, and I don't see it. Right? Because they did a common denominator. I mean, the L is probably not going to matter that much, but I'm wondering why it didn't appear. So how else would you do that? The only other way to do, no, that still wouldn't do it. Because we're breaking it into partial fractions, aren't we?
Yeah.
What if we break this into partial fractions? Let's do it. Let's see if it works. Okay, so I've got this, and so then I would rewrite this as a over y plus b over L minus y, correct?
Yeah.
That gives me L minus y plus b y, right? Equals L. So I set y equal to 0.
Yeah.
I get L equals AL,
Minus.
which can only be true if A is 1, right? So B equals 0. I set y equals 0. I get so A has to be 1. So this is 1, which looks just like what they did. That's a good sign. Let's see if we make the other side work. If I set this equals 0, that means y must be L. Right? If I set that equals 0, so then I get L equals A, L minus L. So that goes away, plus BL, so therefore B must be 1 as well. That's how they did. They did partial fraction.
Yeah.
Yeah? Okay, so that gets us like halfway through the ugliness. To the integral of 1 over y plus 1 over L minus y dy equals the integral of k dt. That's just going to be kt. We know that one. This is going to be with a plus in the middle. I can do them individually. Ln of y plus, it'd be minus, wouldn't it? Because it's because the derivative of the inside would be a minus.
They have minus.
Right. It would be minus on the inside. Right?
Right.
So if I set u equal to this, I get a derivative is negative. Okay. Part of the point of this is we hopefully are not going to have to do this every stinking time. Equals kt. Now what? Or plus c on there. And then we got to do, rewrite it as an ln. Since it's an ln.
Subtraction on the outside, division on the inside.
Uh-huh. So this would be y over L minus y absolute values. No, I got it backwards. How did I get backwards? Whoa.
Because it's negative.
Nelly.
No, that's not it.
That's not it. It'd be this divided by this, wouldn't it?
Oh, well, they just made the entire thing negative. Because on the right side, they have minus kt minus c.
They threw the negative over there to make their lives better. See, this is why this is so much fun. So they made both sides negative, changing the negative of that and the positive over here, so they could write this as negative kt plus c.
Minus c.
Who cares?
Okay.
It's not going to matter, right? It could be a negative c. Oh, here's one. Okay. And then we do the e to the thing,
Yeah.
I think.
Yeah.
We do the e to the thing? We do the e to the thing. E to the negative kt plus c. And then we rewrite this as L minus y over y, absolute value. And then to finish this thing off, we're going to have to move the y up, move this y over. Let's do it.
They didn't do that.
L minus y, yes it did.
Okay.
They just didn't show you explicitly that's what they did. So then they're going to go plus c, move the y out in front here.
Mm-hmm.
Then add the y across. I get y e to the negative kt plus c plus y.
Yep.
Factor out the y. Plus 1 times y, and then shove it all back to get what y is. So you get y equals L over all the garbage. 1 plus, they take the constant down finally, and they make it 1 plus b e to the negative kt. Sorry about that. Okay, so what's the point? Don't do this. When you see a logistical growth curve, write this down.
Is that
do not
always?
What? It always works the same way.
Okay.
L is going to be the limit that the thing reaches.
And
So for
why
the
is-
practice problems, all the answers are going to be this.
The answers are they're going to give you this and ask you for the logistical, for the differential equation, or they give you the derivative and ask the other way, or they ask questions like, well, what's the logistical limit? What's the limit of this equation? So they either give it to you in form B, the actual equation for y, or they give you in form A, the derivative. Either way, you just locate where L is in the problem, extract it, and write down that's the limit.
Okay.
Okay? Does that make sense?
Makes sense.
Okay, so this is a memorization thing. Because otherwise you have to do that.
Wait, can we
And there was 3 or 4 steps where we got drowned in the middle.
can we-
Okay? So example problem number 1 or 10. 10. Example problem number 9. Example problem number 9. No, we don't want advanced problem number 9. Wait, example problem number 10. So example problem number 10, what do? They go dp dt equals kp 1 minus p over 4,000 for a population between 40 and 4,000. They say something about 40 elk in a game refuge. This makes sense of logistical curve. Why? Because what would happen if you release 40 elk into a game reserve? So they succeed at all. They're going to grow to some logical limit, and they're going to run out of trees to hide behind. Right? Okay. Now, so then we look at the problem. It says, write a model for the elk in terms of T. Elk population, the Y equals, right? Or P equals in this case. So what would we do? Simply use the thing we derived for a second ago, right? We're going to go P equals L over 1 plus BE to the negative KT. What is the limit for this particular beastie? We locate the original problem. It's 4,000. That's 4,000 over 1 plus B. Oh, crud. What's B? I forgot what B is. B is important. What's B? B we usually have to solve for. That's interesting. Where would I get B from this mess?
Okay. No.
They ended up with 99. Oh, they solved for 0. They solved for the 0 case. Hold on. We'll just write it down. B, E, K. K population. They don't solve for K. They don't have K either. Darn it. So we're going to have to leave K up there to solve for, and then T. Correct? So far, so good? Okay. And then they say, all right, what do we do to solve?
So what does B represent?
B is a modifier that changes the slope of the logistical curve. Okay? So in other words, that idea where if you're going like this, it changes how fast this changes. And so it's almost always derived. It was the constant in the equation when you take the integral.
Is there, what do we call the point where it goes from concave up to concave down?
I don't know if there's a point. There's got to be a name for it. I just don't know what it is.
Okay, but that's not important to any equations where that happens.
They're going to want to know what the maximum is, and then they want you to be able to do the math to solve the rest of it. Okay, so this is just that idea. The real problem is that the math leading up to this is so hard. I just don't anticipate you going, oh, let me go all the way through all these steps, especially considering it always appears in the multiple choice section. Can't remember the last time it's appeared. I don't think it's ever appeared in the. They got microphones there now, so watch out for that. So then, in order to find what B is, I'm going to set T equal to 0, which is this is our constant, so that makes sense. The same procedure we've always done. Set that to 0. That makes all of this 1, which means when the population, which is 40 at the very beginning, I have 4,000, my maximum, 1 plus B times 1, right? So I can solve where B must be. 99. That makes sense? And then, how do they solve for, oh, they say the population is 104 sometime later. Yeah, population is 104 at 5 years, so how do I find what K is?
Plug in all the variables.
Plug in all the variables, solve what K is.
So basically we just need to memorize this one.
Memorize the two formulas, the starting point and the end point. That's it. And no, you have the idea what an L is. L is the logistical limit. In other words, it's the point at which you can't go past that point. The elks have run out of trees to hide behind. The bacteria have run out of petri dish to grow in. Okay, it's something that's growing exponentially, but suddenly runs into something that's not good. Can't grow beyond that boundary. Does that make sense? That's it. It's just a memorization thing. Okay. Alrighty.